My name is Chris Skaggs, and this is John McLaughlin. We're from Code Monkeys, and Soma Games is kind of the same company, same people, just different brands. What we're here talking about today is our experience with perceptual computing and hands-free UX design. And so we're hoping to kind of give you our experience, what we learned, what we failed to learn, and some ideas about what going forward. Just as a technical note, this whole presentation as a way of a demonstration has all been done using Unity 3D and using the perceptual camera. So if we totally wipe out, that's because we're trying to demo live. But if it works well, you could see some other applications. So let me start with some basic ideas. I know that there are a lot of folks here already talking about the Microsoft Kinect. By and large, we are not talking about that. We're talking about a separate piece of hardware. In this case, it's the creative camera. You can see it right here. It's something that Intel's put a lot of time and energy into recently, and they are available on the market, but they're still pretty early. They're pretty early hardware, and so they're a little bit rough in some places. The SDKs are still kind of finding their feet in certain things. Compared to the Kinect, what's different would be that it's where the Kinect is designed to be sort of a full body, kind of in your living room sort of situation. The creative cameras are designed to be more on a laptop or on a tablet, and so it's more close up. It's more sort of just head and shoulders, your hands, that kind of thing. So you'll be sitting down. That's the imagined use case. So they're relatively short range in the camera. I think the max range effectively is about depth camera. I don't think it goes much more than that. But you've got a nice wide angle camera to kind of get you, even though you're close up. So technically, that's what we're talking about. Although a lot of the concepts between Kinect and the creative and the perceptual computing will be similar. So that's what we're doing here. And something to think about on some of the key abilities of the cameras is hand and gesture recognition. So as a rule, you have units in the SDK that will recognize your hand configuration, the bones in your hands, so it can figure out, if you're making certain gestures. It is better at recognizing some gestures than others, and we'll get through that. It does have 3D depth with a infrared strobe. And that works pretty well, up to about 3 feet. It also includes a voice recognition software, so you'll see us using some commands to drive the presentation forward. And that works pretty darn well. And in the near future, you will expect to see some of these cameras coming out in Ultrabooks and also in some tablets coming up in the near future. We're hearing like Q2, Q3 next year is roughly when you start seeing them on the market. So roughly, that's kind of giving you a head start on where we are technically. And we'll just move on to what we were doing UX. This particular session, we wanted to talk about the considerations specifically about how you design for UI and UX. The main thing here we were trying to understand was what are the specific uses that go into this kinds of hands-free experience as opposed to something we're more used to. I would submit from the start that when touch came out, especially for tablets and iPhones, that one of the things that happened there was that it removed one layer of abstraction between what we're expecting to do with our hands and what and the way that we generally anticipate using the world. So instead of a keyboard or a mouse, we've sort of touch brought us sort of one layer closer to the things we were doing. Touch became, in some ways it became only an analog for something else that we were doing in another metaphor. So you'll see games, for example, where I put my thumbs down in the corners and they become virtual joysticks. And I would say that's probably a poor implementation of touch. It may be necessary for your game, but as a rule, it's not using touch for what it's worth. It's just sort of simulating some other design modality. Hands-free is another layer. So I would argue that its real strength lies in the possibility that you can have a 3D person interacting with a 3D virtual world, and there doesn't have to be the compression of 2D in between. So if you imagine the compression I'm talking about, one of the great examples of that would be when you go to prison, if you've ever been there, and you're talking to someone through the phone, right? Here's these two 3D worlds completely separated by a 2D space, and so all of the interaction gets compressed into this plane, and so all you have is a phone. That's the kind of thing that can make what's possible with 3D cameras and with motion control cameras. It can make that whole experience feel really gimmicky and not particularly useful. It was Gabe Newell, I think, from Valve, who was talking a while back about one of the reasons they had not gone too far with Kinect and that sort of thing was that he observed the basic latency that came from, it's a lot harder for me to go like this just in terms of milliseconds than it is for me to go like this with my thumb. So for games that required really quick response time, touch was actually a move back, and perceptual was even a farther move back in terms of the experience that I want to do. So what we hoped to do as we started moving the Stargate game was, what can we do that actually makes the experience better using the technology, not just the fact that someone paid us to make a game using a new camera. So we wanted to make something that actually changed the way that it worked. And I think the key consideration we thought was that old control schemes don't have any business going forward. An example of this is a button. You know, long ago, when people were making typewriters, or who knows where the first button came out, this was a metaphor for a mechanical link. I pushed the button, it did something. Now that might be that, you know, on a typewriter, I push the L, which swings a lever, which hits the ribbon, which leaves ink on the paper and swings back down. So there's this whole chain of events that happens with a button. And coming forward, all we've done is make that even more metaphorical. So now we've created an image of a button that pretends to go up and down on a 2D surface. And so we've created these metaphors that are stacked upon each other. And they have not gone back to the core principle of what am I actually trying to do. Another great example of this would be when you see the voicemail icon on your phone and it shows a little cassette tape. And none of us have probably seen a cassette tape in 20 years. But somehow we go backwards to these metaphors because we have a difficulty moving away from what we already know. With Perceptual, the impulse that we first went to is the same stuff that everyone does, is how do I make a game, for example, that I'm already familiar with. That might be a shooter or a racing game or anything else. How do I take that control scheme and make it work for this? And the most natural place to go is just sort of to translate one more level of abstraction. So now instead of me moving my joystick left to right, I might tilt the tablet left to right, or I might use a virtual joystick on the touch. That would be a really natural way to do it, but it's actually the lazy way to do it, I would suggest. It further abstracts instead of de-abstracts what you're really trying to do. So the button became sort of this thing for us. It's like, why do we have stupid buttons in a game where there's no reason for me to press any mechanical linkage? And that sort of went down a whole way of thinking for us that it's beyond the scope of this conversation, but it actually made us re-examine how we did our touch interface too, for the same reasons, as we had come to recognize how many old broken metaphors that didn't really apply that we were naturally bringing forward. So a really good example of this in this game was the menu system. And so real typically I've got my home page and some amount of information that I need to organize and display for you. And that's everything from the credits to the upgrade screens. All those things we are used to using these stacks of 2D planes as menus that I drill down. So I need to go to my weapons menu, which brings me down to my gun menu, which brings me down to my upgrade from level 4 to level 5 menu, which lets me go to a purchase price to do the time gate. You've got this huge chain of 2D planes that are just in my way. But instead, we decided, well, what if we just rethought this, and what do I really want to do? And I think that with Perceptual, it opens up this idea of 3D to 3D. I have a 3D human who naturally experiences his world or her world in 3 dimensions all the time. And we are constantly throughout our lives learning to organize the things around us spatially. It's very natural. It's the way that babies learn, you know, blocks go on top of blocks, all this kind of stuff. And it's super visceral. So if we could figure out a way to organize information spatially, what we found is that it was way more intuitive to work with, and that I retained it much better. So to go back to the menus, for example, if you wanted to configure your spaceship for the mission, rather than this series of menus to assign weapons and upgrades, why don't I just pick up the gun and stick it on the spaceship? Why don't I just use an object and create these 3-dimensional spaces? And in some cases, we did them as rooms. In some cases, we did them as the objects that you're already doing in the game. And the more that we could make that tactile to some degree, if you can, allow me to do that, and there's the game that just bumps up. The more that we could make that tactile, your brain, we found, picked it up really, really fast. One of the other unexpected things that we did, I'll get to that in a second. The notion that I wanted to go to is that we believe that, contrary to the incredibly intelligent gentleman that I heard speak about Connect earlier, I disagree with everything he said regarding symbolizing actions in a Connect or a space. I think the more that we move towards symbolizing actions, the less intuitive and the less fun the experience becomes. And then these cameras, like Connect, they just become gimmicky. And I think that's been really the hard thing for when we started with the Wii and now the Kinect, is that it's been difficult for game designers to figure out the space that actually works. And it always feels like, hey, I'm just exercising, and the reality is I'm lazy and I don't want to exercise. And so I don't want to be jumping up in the Wii Fit, unless I'm there to be exercising. That's not the experience that I desire. It's forced upon me. And similarly, it's the nature of the latency that Mr. Newell talks about, that an experience that requires really quick, precise movement is not well suited to this environment. So when our game design does not account for our physical sort of meat space, then it just becomes, we have to bridge that gap in an unnatural way. The more that we can find a game experience that mirrors a real world experience, the more natural the tool works, and it works to its strengths, not to its weaknesses. So as examples of this, we found that inertia was one of the most natural places that we could add to a game. Obviously, you're adding to it just virtually. But whenever, instead of instantaneous velocity, for example, when I'm moving a hand or I'm moving an object, just the idea that there had to be an acceleration and a deceleration of that object, you could really naturally convince people that this had weight and that this object had more weight than that object, that even though there's no feedback in my hands, I felt it by seeing it. And so when those motions were reflected on the screen, it became very satisfying and very natural. Those ideas also that if a thing, if it required, if we wanted in the game design, if we required that it had to not only require additional time and energy to start, but it also required time and energy to stop. That became a really natural thing to add into the code that made the whole 3D perceptual experience much more connected. It didn't feel that I was at a distance from the thing. I've already talked about spatial orientation. That my brain, what we found is that it was remarkably natural to think in my mind, what are the things that are behind me but off screen, so long as I had taken a step ahead of time to arrange them in space. So you might imagine that if I'm showing a player as that they're in the cockpit of a spaceship, if somewhere along the line I have already visually oriented them that some other thing is behind me, that might be the tail gun, or it might be the little lever that reloads the gun, whatever it might be, if they already know that, they retain it very naturally and they go right back to it very quickly. It becomes the more I can organize my data, even the most mundane data like credits or that kind of thing. You can arrange, for example, a credit screen with just people. Instead of making a list of names, like, here's Bob, shake his hand. That kind of stuff becomes incredibly natural and fulfilling. The other thing we found is that the experience can be much surprising depending on what we thought. So when we do touch on Stargate Gunship, and you'll get a chance to see this in just a second, when we do it in touch, it's a fairly twitchy game. It's fairly fast-paced, and you're moving through it pretty quickly. But what we discovered when we put it in hands-free was that the inertia of the hand motion became actually really meditative. And the truth is, I can't explain this, but everyone who plays it goes, this is really calming, man. Like, I'm shooting the Joff when they're blowing up, but it's really chill. And so there was something about the slowness and the interactivity of it that created a very different experience than we thought. We have yet to actually do anything with that experience, but right now it's just an observation, and it was not what we anticipated. And it was certainly remarkably different from the touch and from the joystick experience. So I think what happens is that the more our bodies are kinesthetically involved in these things, we're tapping into certain aspects of emotion and of probably hormones and dopamine and who knows what else is going on in there. But it's a radically different experience than sitting on your couch twitching with your thumbs. And I think that when we have opportunities to actually play on that, which we'll talk about a little bit later, we're going to see something really, really different. So we're going to move here.
So we're going to do a short demo so that I can talk about the more normal aspect. And so if you can see, I'm doing the peace sign to the camera because it's a normal situation. And if you watch the hand up above, you can see that it twitches a lot around. That is partly due to the wonderful, terrible resolution of the depth camera that they currently have. Now, they say that it's going to be better. Now, Kinect, it runs at about 1080, which is great. This one is 320 by 240 for anyone that actually cares about numbers.
He's too close. He's too close.
Pause.
He's too close. He's too close.
Did it still go? Nope.
If they're still moving in the background.
And so from that demo, you could see that the actual camera coming in is jittery. And, you know, the real number to that is if you put your hand about a foot away, 320, it ends up being each pixel is about a half a centimeter in size that you're going across, which means, you know, when your hand is twitching a little bit, it ends up twitching several pixels that are returning to me, and then you try and convert that. Thankfully, this is a low-resolution projector, but when you go to something like 1080p, those pixels end up being about a 1 to 10 ratio, which causes a very jittery interface. And if you use that as your direct interface, you're not going to have the feel that a user wants, because where the user points, he wants to target and feel like that makes sense. And so what we did is we have what we're calling a motion buffer. Basically, I take the input I'm getting from the camera, put it in a 10 long array, step it down, and right, down is close to done, I understand. So we're running this through the voice commands, so that's why it switches back every once in a while, because if we get a word close, it's going to assume you're talking about something else. And by doing that, there is some latency, which is probably why it has the slow feeling, but it makes it so your target doesn't jump around when you're trying to shoot something, because you can feel the movement, and it makes the error lower. We found that trying to use a thumbs up was terrible. That even though it comes part of the camera and it's supposed to know how it works, that this thumbs up is different than this thumbs up, which is different than this thumbs up. And the camera wants this one, straight on with your whole arm. And if you don't do that, it doesn't know it's a thumbs up, which is why you want to use, it understands peace wonderfully, and no matter the angle, it can find this simply. And so we use this as our centering tool. So if for us, if you show a peace sign, it'll center to where you're trying to aim, and then when you go back, you can fire and not fire. We removed the need to do a twitch firing because it's not fast enough, so it's an auto fire like you're trying to fire a machine gun. And we have had a fun time trying to figure out how to make head tracking work correctly. We were part of a challenge through Intel, the Intel Ultimate Coder Challenge, focusing on perceptual computing. And with that, there was a lot of people that did head tracking. But for a game, your input can be about 3% of your total input scheme. And with that, we can't use their solutions for head tracking. They had some great solutions, but it required about 50% of a processor, which is not tenable for any game situation. And so when you're trying to make the interaction between your head and the camera, especially at the low resolution, we just couldn't find a solution that didn't feel wrong. And so we ended up having to remove it.
One of the things that you saw there briefly that also worked out to be really well was that there's a step in that game at the very beginning where you allow the user to orient themselves to the game. And so when John told you that the peace sign becomes an orienting feature, what happens is the camera sort of invites you to say, you know, show me your peace sign, and then the person's able to put up their hand and kind of find the sweet spot, because often between the depth and where they want to hold their arm, they got to find a spot that works for them. That became a place where the camera, for all the low resolution, it spits out just a truckload of data, and frankly, way more data than we needed. Realistically, in any given spot, I really only care about maybe 20% of what the camera's seeing. Most of it else I want to call out. So by using that, we did a couple things, is that we orient the camera in depth so that by and large, people's hands don't drift too much in depth. And so once they've oriented, they stick to where they're going to be, and they're going to move their hand basically on this plane. And we can filter by depth to kind of see where that's going. Head tracking became a lot harder. One is that your head's just a big old blob, and it was difficult to see it, especially in a demonstration perspective, that it didn't confuse your head blob with a lot of other blobs. It became a difficult piece. And more importantly, even if it was technologically possible, we found that experientially it sucked. I didn't really want my head to be the tracker. I don't like to have to go like this because I feel like I get sick on a ship. What I really want is I want gaze tracking. I want it to know where my eyes are. That's a long way away. So in the end, the head tracking became something we mostly got rid of because even if we could do it, it just wasn't good. It wasn't fun. It didn't make for a better experience, even if it made sort of a technical reality. I know we're on a pretty tight schedule, so let me try to move on. What we see coming up, some things to think about as game designers, is that, as I mentioned, the next resolution of these cameras are coming out really quick. So probably in the next quarter, 2 quarters, you're going to start seeing these things show up on websites because there's a big effort to get these as normal elements in commercial products. And so especially in laptops and tablets, you're going to see this a lot. While we came from a gaming perspective, you'll see that there's actually a lot of opportunity to use this technology in totally different ways. So as an example, you might imagine that cameras with wide-angle lenses that are down low on your bezel, for example, might be allowed for me to have a simulated keyboard. So that if it's nice enough that it can tell where my fingers are and I can sort of understand a little bit of depth, a real simple piece of paper keyboard, it can notice where the letters are, and I can type on any surface because the camera will see that. You're going to see multiple cameras probably in some of these things that do different things. One's going to look for your head, one's going to look for your hands down low. These kind of things are becoming much more interesting. The question will be if people decide to use them, if developers find it to be an interesting modality. On the opposite end, this goes back to our question about, we believe that probably the real strength of this tool is any place that the camera can be, put you in a place where it represents a more real-world perspective. But for the moment, the 2D screen is still a radically limiting factor. Everything in your 3D world has to squeeze through that piece of glass and out into another 3D world. But places where that could disappear would be really intriguing. So for example, you could have the surround video, sort of the full body stuff, places like that where, or with geolocation, for example, if I'm somehow using this technology in the real world, there could be some interesting applications here where the physical world and the virtual world mesh in a lot tighter space. Some speculations that might be out there, and I'm sure that this needs a whole lot of SDK work, but it would be really fascinating, would be the ability for the tool to recognize also your emotional state. So you might, for example, have a game where if it's got a long expository scene, and you see it like this guy with his arms crossed, this guy's bored as hell, right? And so if the game notices that and says, okay, let's rush it along already, right? Or if you see somebody gets the big, like, epic win smile on their face, it's like that's when you ask them for money. Whatever the situation is, the camera if it can recognize expressions and emotions, would be a pretty radical change. Gaze tracking, we mentioned, is sort of the holy grail in that respect. I really want that helicopter cyberlink thing. So when I look, wherever I look, that's where the chain gun's pointing. Right now, that's been a challenge, although I imagine it's probably going to be one of the first things people really jump at because it's a really rewarding and quick experience. It includes also the ability to have biometric input. So the idea, for example, if the camera can sense, for example, say your pulse, it can, if it's sensitive enough to demonstrate the heartbeat on your throat. These kinds of things could be done in a really natural and unobtrusive way, so I don't have to wear the little finger clips or anything like that. And biometric input could be done also at depth layers. A lot of the cameras are using infrared or even UV in some cases, so there's some backscattering underneath your skin as well. So there's some things that these cameras could do that, to my knowledge, are not being done yet. So John says that, can we say that? Maybe not. That's maybe on the phrase here. So. We were asked to give just a couple minutes. If you'd like, John, could you just exit this so they can see the Unity SDK?
All right.
And we'll start with some Q&A because I know there was some time for that about either how the code is done or what people are saying. Like I mentioned, this whole presentation we did through the Unity engine just as a demonstration. Intel releases their SDK as a free download, and it's pretty sharp and it's getting better all the time, and that's what we worked with. So, are there any questions or anything that we can share? Yes, sir. Yes, please.
Yes, please.
So I've been playing around with the Leap Motion a little bit, and I'll just express my opinion. I'm just curious what you guys feel about this. I found a lot of games that are gesture-based only with no keyboard interaction. I think pretty much all the Leap Motion apps that are out there right now are that way. And I feel like it lends itself to being more gimmicky when they don't take advantage of all the control inputs. So there was a game that's kind of similar to yours, the Blue State Prologue. I don't know if you've seen it, where it's a rail shooter,
Yeah, actually, this particular thing has three. The same executable does both touch, keyboard, and perceptual, and you can mix and match. So for the demonstration, we wanted to do it hands-free, but you can do all.
So we have mouse support, and so you could actually target and fire using the mouse, and we could remove the need to target using the mouse and just make it so the mouse clicks or spacebar, and so that is possible, and it's in Unity, and this is about Perceptual.
Yeah, I think your core concept is really true, though. It's like you want to find the modality that actually adds to the game experience, not force someone into a tech showcase. Anybody else? Okay. Well, I don't know why they gave us the big room, but I appreciate you coming to the big, giant theater. And thank you very much. I hope to see you around.